Hey there, glad to see you back at the Enclosure Institute. I'm Phil Taylor.
And I'm Jimmy Budd. Today we're going to discuss some considerations that come into play while choosing a pressure-sensitive adhesive for enclosure components.
Many of the components that Marian manufactures for enclosures include a layer of pressure-sensitive adhesive. When it comes to PSAs, we have a long history of experience and expertise in material recommendations and manufacturing.
When talking about gaskets, seals, vents, vibration-damping cushions, and other components, the designer is eventually faced with the challenge of putting the component in place and keeping it there. That's often the role of the PSA. But there are a number of questions to think about to select the best or most cost-effective PSA for your application.
One of the first questions to ask yourself is, what exactly is the purpose of the adhesive in my application? Many gaskets require a PSA backing to simply hold the seal in its intended place during assembly, whether that's by hand or automated placement. In many situations, the PSA layer can improve the ability of the gasket to maintain its seal. If the gasket is sealing in a dynamic application, where it's expected that the gasket will be compressed, released, then recompressed over and over, the adhesive must be more robust and have a higher adhesion level than might be needed for a static gasket that's compressed once and never meant to be released. Some static seals experience very little stress after compression. In that case, the PSA is simply an assembly aid. But other static gaskets will experience high pressures, vibration, abrasion, and need more aggressive and long-lasting PSA that will enable the foam to perform its function over a longer period of time.
PSAs come in various forms. Oftentimes, a double-face PSA is chosen to act as a stiffener and gives the flexible foam component geometric stability by restricting the foam from stretching. In other cases, a transfer tape is used to prevent the adhesive layer from restricting the foam's ability to flex, turn, or bend. Repositionable adhesives, similar to that of a Post-it note, can also be used so the components can be easily removed and repositioned as needed. With these products, the adhesion to the foam gasket is significantly greater than the adhesion to enclosure sealing surface.
Next, let's talk about the nature of the surface to which you will adhere the component. Different substrates have different finishes and energy levels. So surfaces like steel, anodized aluminum, plastics, and more will each respond differently to various adhesives. If the surface you'll be adhering to is painted or treated in some way, that'll make a difference. Is it smooth, rough, pitted, as cast, or porous? The answer will affect the type and thickness of the PSA needed. We'll discuss different adhesive types here shortly.
Another consideration that will affect your choice of adhesive types is the stress that may work against the bond. Peel stress pulls the component up and away from the surfaces it's bonded, like a banana skin is peeled from the fruit inside. Shear stress, on the other hand, pulls or pushes the component parallel to the bond line. Some adhesives are better suited for peel strength, while others have higher shear strength.
And just as you were encouraged to consider the best foam for your gasket, the environment in which your component functions also plays a significant role in your PSA selection. Consider the temperature extremes, both high and low, that your device is intended to function. Will the component be exposed to UV, to solvents, to cleaning solutions or chemicals? These too will affect the choice of the PSA for your application.
So now let's finally discuss the types of PSA available. In general, there are three basic types or families of adhesives and pressure-sensitive adhesive: rubber, acrylic, and silicone. And as you might suspect, each is better suited against some of the external forces than the others.
Rubber-based PSAs tend to be thicker with higher initial tack when compared to others. In our industry, rubber-based PSAs are often said to have good thumb appeal because they're gooier. Is gooier a word, Jimmy?
Maybe it's not very technical, but I think they get the idea.
Rubber-based PSAs bond well to paper, cardboard, and other fiber materials, but they have the shortest service life and tend to dry out over time. Generally speaking, rubber-based PSAs have the least resistance to high temperatures, UV exposure, and solvents.
Next are acrylics. Acrylic-based PSAs make up the vast majority of PSA products available. While the initial tack is lower than rubber-based PSA, the ultimate bond, after 72 hours, is typically greater and will continue functioning for much longer, if not indefinitely. Acrylics perform well in applications with exposure to UV and many solvents. Acrylic PSAs can also bond well to the vast majority of surface types, with the exception of silicone surfaces. Some acrylic PSA products, but not all, can perform at elevated temperatures, approaching 250 degrees Fahrenheit.
Finally, we've got silicone-based PSAs. They will withstand higher temperatures than rubber or acrylic-based PSAs, and silicone also gives the best performance and longest function in environments with UV exposure. But a silicone PSA is the most expensive of the three choices. Its adhesion may also be quite low to many surfaces except silicone rubber, silicone foam, and other silicone-treated surfaces, where it will afford the highest adhesion levels on those surfaces.
On the same topic, silicone is a low surface energy material, which makes it difficult to adhere to other materials with higher surface energy, unless the silicone is treated. Because of this, a silicone PSA is often laminated to a silicone rubber or silicone foam because low surface energy materials like to stick together. However, silicone can be corona treated to change the surface energy from low to higher surface energy. Corona treatment is a capability of both Marian and Rogers. This process allows acrylic-based PSAs to be laminated to silicone rubber or foam with a high bond level. An acrylic PSA is less expensive than a silicone PSA and it offers more versatility.
Now let's revisit the topic of PSA product constructions. As we mentioned before, there are double-face tapes and transfer adhesives. Transfer adhesives are thin layers of adhesive carried on a protective liner. When laminated to the foam, they simply provide a thin line of adhesion. Once the liner is removed, though, they don't provide any dimensional stability to the gasket, but they are often preferred when the gasket is very thin and used to seal small enclosures such as handheld electronic devices.
Double-face tapes make up the vast majority of PSA products. Adhesive layers are coated on each side of a central carrier film, such as polyester, paper fiber, fabrics, or foams. As we mentioned earlier, the double-face construction helps provide dimensional stability to the gasket shape. Many of these two-sided tapes are coated with the same adhesive type on each side, but some are available as differential double-face tapes. In this case, they may have a rubber-based PSA on one side and acrylic on the other. Or it could be acrylic PSA on one side and silicone on the other. Or maybe both sides are acrylic, but of different formulations for different bonding levels. There is no right or wrong combination, it's all dependent on the application and its use case.
Another consideration is the geometry of the adhesive layer. The adhesive layer of a multi-layered component is typically the same geometry as the foam. In those cases, the adhesive layer fully covers the sealing surface of the gasket. This is the most efficient and cost-effective design, but adhesive placement isn't limited to this design. In some applications, such as a vent, the adhesive layer may interfere or impede the functioning layer. The adhesive layer can be cut independently of the foam or vent material, and then strategically and precisely placed in the desired location. We call this method zone lamination.
The next consideration to discuss in relation to PSAs are their protective liners. When your team is ready to assemble the component, the liner on the adhesive layer needs to be removed cleanly, completely, and quickly. Understanding how your component will be assembled is crucial to this consideration. Liner type and shape relative to the component's geometry are both important parts of determining how your custom components will be presented to you, and also help determine the manufacturing process used to cut these parts. Some components are best supplied kiss-cut continuously on the liner's roll, while others may be better cut as individual parts with an extended pull tab on the liner. These are just a couple of the many available options.
Finally, but not least importantly, we always encourage you to consider availability and cost. There are tons of high-performance materials to choose from, but choosing one that's more costly without good reason could mean you're paying for unnecessary features. There's no need to over-engineer a component with high-powered adhesive when a more cost-effective alternative will function well and for the lifetime of your application. It's also important to be aware of the volume or quantities expected or forecasted. Even though each Marian location maintains inventories of hundreds of PSA products and has access to thousands more, not all choices are available in every country, and some PSA products require a large minimum buy that could negatively affect your cost. We can guide you to your best options based on your volumes, location, and project timeline.
Well, I think that about wraps it up for today. We hope you learned something and that it all sticks. I think your humor's rubbing off on me, Phil. Remember, we can help guide you through your adhesive selection in the same way we can help in sealing material selection, including providing material samples, technical data sheets, prototypes, and rapid quotes.
Next time, we'll review an application story that we hope will provide some insight into some of the design considerations that we've been discussing so far, and also demonstrate how working with the right partners can help your application grow from an idea to a real product. And until then, you guessed it, I'm Phil Taylor.
And I'm Jimmy Budd. We'll see you soon. Can't believe I made a tape joke.
It's all right. It's all right. I try not to get too cut up about it.